Hey guys, welcome back. We have been working on different digital sensors, and today I'm going to start working on a new digital sensor that's TSL2571. Now to explain more about this sensor, let's have a look over the website that is controleverything.com and here search out for the sensor that is TSL2571 and let's see what we got. So we got that TSL2571 is a light to digital converter programmable analog gain. It's a light sensor in short, and as you can see, these are some of its features which you can have a look over. Now you can also have the purchasing power from here, you can add to cart here. Now for this video tutorial, I'm going to interface the light sensor TSL2571 with Raspberry Pi and I need a Python code for that. Now let's have a look over the Python code sample from the resource tab and you can have the opportunity to download as zip file from here. Also, you can download the code from GitHub repository and it's called Control Everything Community. Now, let me show you the hardware we require so that we can interface the sensor along with the Raspberry Pi. This is our sensor, that is light sensor TSL2571. Now, this is a Raspberry Pi and these are the GPIO pins of the Raspberry Pi. Now, the first connection is to be among the sensor and the Raspberry Pi, and to make a connection among that we need an I2C shield which you are able to see on my screen and it's available on the website controleverything.com. Also, to make further connections with other I2C devices and make that connection a lot easier, we need this I2C shield. Now, gently place over the I2C shield over the GPIO pins of the Raspberry Pi and make a connection. Next connection should be among the sensor and the I2C shield, and we need a connecting cable just like this. Now put up a connection among the sensor and the cable, and while making this connection, make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly for the I2C shield also. Now to power up the Raspberry Pi, we need a micro USB cable just like this and gently insert it over the power jack. Finally, the last part is to make an internet connection. We have two ways. First of all is we need an Ethernet cable just like this and gently insert it over the Ethernet jack. Next, if we don't have the cable, we can also use a wireless nano USB adapter to connect to the internet, and we are done with that. Finally, as all the connections are being set up, next we need a code so that we can interface along with the Raspberry Pi and the sensor. Now for the interfacing we require a Python code, and the best way is to get to the website github.com and here search for the repository that is Control Everything Community. Now click over here and search for the sensor that is TSL2571. Now this is the Python code. But before that, let's have a look over the instructions we should follow. It says that we have to download and install SMBus library on the Raspberry Pi, and the steps to install SMBus are provided on this very link. Let's have a look over this link so that we can familiarize with ourselves with the instructions we need to follow, the commands we should follow. Now get it done, and this is the command to run the Python code. Note it down. Now this is the Python code we would like to explore, and it's a .py extension file. Finally, for the explanation, we have to import SMBus and time, and these are the libraries. Now we have the address of the sensor, that is 0x39. Now comes the writing part where we have to select enable register or with command register 0x80, and the command we are sending here is to power on ALS enabled, and it's here. Next we have to select ALS time register having address 0x01 or with command register 0x80, and the command we are sending is 0xFF comprising A time equal to 2.72 ms, max count equal to 1023, and here we go. Next we have to select wait time register having address 0x03 and the command register having address 0x80, and we are sending the W time equal to 2.72 and it's 0xFF. This is the writing command. The last command is to select the control register having address 0x0F with command register or with 0x80, and we are sending gain equal to 1x and it's 0x20. So there is a time.sleep function for 0.5 seconds, as you can see. After that, we have to read 4 bytes of data for the luminosity, and it's channel 0, channel 1 data, as you can see. And after that, we have the conversion of the data takes place. There you can see a lot of dependencies on the if condition and the formulas which are being provided in the datasheet for TSL2571. Finally, we need to have the output data to be displayed on the screen, and its ambient light luminance in lux. The unit is lux, and we have formatted the data to the exact two values or two places of floating point value. So what do we require to show the working of this Python code alongside the temperature, the sensor, the light sensor, and Raspberry Pi? Let's have it. Now for the practicality of this code, first of all we have to copy this entire Python code as you can see on my screen and go to the terminal, VI terminal for Raspberry Pi via internet. Here create a new file in the VI editor, TSL2571.py, that's the extension, and here paste the entire code and then save it. Now it's time to run the code as you can see on my screen, and here we go. We had ambient light luminance and it's in the lux value as you can see. Now when I again run the command, there is a very minute change, but instead when I place some object over the sensor, you can see the light luminance is decreasing. Now again when I doing that, it will decrease further. Now instead of that, if I put some light source near the sensor, you can see the increase in the ambient light luminance. Here we go. As you can see, there's a high increase in the ambient light luminance in the lux value. So this is how the Python code works. Now what do we require is to have a look over the benefits, the features and the applications regarding the sensor TSL2571. Let's have a look over there also. The TSL2571 family of devices provide ambient light sensing (ALS) that approximates human eye response to light intensity under a variety of lighting conditions and throughout a variety of attenuation materials. While useful for general purpose lighting sensing, the device is particularly useful for display management and with the purpose of extending battery life and providing optimum viewing in diverse lighting conditions. Now these features make it very useful for applications like display management, backlight control, cell phones, PDA, GPS, notebooks and monitors, LCD, LED TVs, and a lot more. Now you can have the opportunity to purchase the sensor from the website, that's controleverything.com, and you can have the code from resource tab. Now also after that you can download the code from there. Well, you can also have the code from GitHub repository, that's Control Everything Community. Now in the end, I would just like to make it clear that in case you guys are in kind of feeling that you are left without fully understanding, you can have your queries on controleverything.com, and also you can post your comments on the community page of this website. For articles and blogs which are relevant to this video, you can contact us on instructables.com, and to subscribe more video tutorials which are relevant to these videos and tutorials, you can go to YouTube channel. In the end, I hope you enjoyed this video. You have a good time. Thanks for watching.